This is section 5.3, and today we're doing angle bisectors. Previously we've done segment bisectors, and now these are going to cut angles in half. So just still more of us setting things equal. As soon as we have a bisector, we have two parts that are equal. So the angle bisector theorem just says if a point is on the bisector of an angle, then it is equidistant. There's our word again, just saying that things are the same distance from both sides of the angle. So that means if I have an angle bisector up the middle and D is on it, then it's the same distance. BD is the same distance as DC. It's the same distance from both sides. Okay? Converse of the angle bisector theorem. So we want to say it in reverse. So if a point is inside an angle, so if I made an angle, it's got to be inside the angle, and is equidistant, from the sides, then it's on the bisector. So kind of just saying it both ways. If the point is in the middle and it's equidistant from both sides, then that's on the angle bisector. And the other one is saying if it's on the angle bisector, then it's the same distance from both sides. What that really comes down to is just a lot of things are equal. In this chapter, it's a lot of parts being equal because of the bisectors cutting everything in half. So this first one says find the measure of GFJ, that angle right there. I know this guy is a bisector. I have two pieces of information. I got the 90 and I got that this is 7 and so is this one. So if J is the same distance from both, then this is the bisector, so that makes that angle 42 degrees. If P were on the bisector, solve for X. So if there was a bisector here and P was on it, that would mean that the distance here has to be equal to the distance here. So solving, I would minus my X over and add my 1. Okay? A couple more. The first one has, you get information where the angles are equal, and if that's true, then this is a bisector because it cut that in half. So that means that that has to equal that. So X is 15. This one I've got the 90 and the segments are equal. So that means these angles are equal. So 3x plus 5 has to equal 4x minus 6. I'll minus my 3x over and add my 6. Last one, I've got 5x and 6x minus 5. I get two things. I get that it's the angle bisector because these two arcs mean that the angles are equal. And then I get the 90. So this guy has to be, those have to be equal to each other. 6x minus 5. So minus this guy over and I'll have x and then add my 5. Last one, is there enough information to prove that QS bisects angle PQR? So right now I know that P to S is the same as R to S, but what I don't know is if they meet at a 90. And I don't know if the angles are equal. So this is not enough information. I need more information to be able to tell if that is actually a bisector. Either I need to know the angles were cut in half, or I need to know that these are both at 90 degrees. I could, with a line up the middle, I could say that that distance equals that distance, but I don't know that this guy is the angle bisector. So you want to be a little careful of that, okay? So you need two things at least to make sure that you've got a bisector.